Hello, welcome back to another session of Astronomy Unanswered Questions with Mr. Mikulski. This is going to be part 4 of our multi-part series. Good evening. Today we're going to go ahead and start answering some questions from Celestial Owl. Okay, so Celestial Owl says, we're going to write more than 3, so pick out your 3 favorites. All right, that's going to be hard to do because I haven't read them yet. So let's see if I can read them and we'll see what we can do with these. There's quite a list. All right. Number 1, would it be possible to use the properties or concepts of quantum foam to make a device that creates matter and antimatter at the same time? I'm going to go with yes, but actually, I don't know. I'm not as familiar with the whole quantum foam idea. I believe it's just kind of similar to um, like in string theory, the base, like backbone, if you will, although not a bone, but the substance, if you will, that makes up kind of the underlying material of the universe. I could be wrong on that idea, but the idea in general of creating matter and antimatter at the same time, that one definitely is not a foreign concept. That one does occur, and I think it is possible. I think, in fact, we do this, and we being like scientific humans, that they can. I believe it's usually in the particle accelerators that in a collision. I think it can create this matter and antimatter at the same time. However, it's really hard to create in a certain amount of specifically the antimatter part. But because of the law of conservation of matter, it's kind of like if you were to create matter from what would seem to be nothing, then by consequence, you would have to be creating antimatter. The problem is, anytime antimatter comes into contact with regular matter, it annihilates. And that annihilation is, from my understanding, anyways, it's about as powerful as, like an atomic weapon in the sense that the energy it gives off is immense. So that also creates a problem. I know people have thought about possibilities of how to store antimatter, and my understanding is that we have been able to store some, but you're talking like, I don't even know if micrograms is the right unit for that, but a very very small amount to be certain. And the reason is that, again, think of a container that would be made of a substance, so that way it could hold another substance that can't touch stuff, just to put it as much layman's terms as possible. So the antimatter cannot come into contact with the container itself, yet the container would have to hold essentially the antimatter, so that way we could store it. And so my understanding is it's using magnetic fields and lasers and things like that. But anyways, that's a very deep. I don't know if it's a deep question or just one that perhaps my knowledge is limited on. So that's about as much as I can offer on that one. All right, let's go on to number 2. How close do you think we are to creating a Dyson sphere like structure? Do you think we as a civilization are at all ready for a project of that scale? Okay, cool. So we've talked about Dyson spheres in class and the idea of the Kardashev scale or Kardashev scale, um, and that we are less than a level 1 um, civilization, but that at, in theory, a level 1 ish, 1, maybe even a level 2. The idea being that we could harness and tap into the 100% of the resources of our solar system, including the sun. And so the Dyson sphere, I love the idea of these being like, basically imagine putting some sort of a ring or a sphere around the sun with solar panels, and being able to capture that energy from all different directions, and then somehow shoot it back to Earth and use it. The amount of, and I hesitate to call it free energy, but renewable resources, right? The sun's not going to go out anytime soon, so the energy from the sun itself is free. Now, the cost part of it would be in producing these solar panels or these devices to capture that energy from the sun. Um, and then, of course, how to transmit it efficiently or effectively. But that would basically give us as a civilization almost an unlimited supply of clean energy. So from that standpoint, that's a super exciting prospect. How far away is that? I think there's some estimates that for us as a civilization, again, we're in like the 100-year range. I think before we could even start touching things like that. I think we could have something along the lines of a Dyson sphere, the concept of it, but maybe not a full sphere or even a shell type structure. The other issue becomes if you want to make something and let's say surround the sun with it, the sun being about what is it? I forget, like about a million times the size or the mass of the Earth. Definitely the mass is 10 to the 24th versus 10 to the 30th power, right, of kilograms. So definitely about a million times the mass of the Earth, but the size is still quite a bit larger. And to make something physical that would go around the sun and yet not be so close to it to like burn up is incredible. I mean, imagine just make a loop that goes around Earth, like out in space. Maybe like at a suborbital level or low orbit, Earth orbit, and try to make it with anything. And how much material, how many supplies, and what's the structure? How do you make a structure that once it's a full ring, yeah, I think it could be supported because you could balance the effects of gravity would act on all parts of it at the same time. But if it's not a ring, then you gotta like shoot it like in orbit around the Earth so that it's essentially spinning until you finish creating it. And then you've got this spinning ring. And I don't know if the spinning part would help or hurt as a solar collector of sorts. But anyways, I think it'd be a monumental task. And I think it's exciting. I'd love the idea of it. Definitely not going to be in my lifetime, unfortunately. All right, that was a little long. Let's see, keep going. Why? I want to know a little more about solar sails. How exactly do they work? Okay, I know they can make very light spacecraft accelerate, but would it be possible to make a modern day spaceship use them without being too much of a hassle? So my understanding is solar sails take advantage of something called solar winds. And if you think about the fact that like the sun emits energized particles everywhere, then those particles have their own momentum, and that momentum can bump into another object and cause that other object to move a little bit. And so, if that other object is very light and very large, large being like, you know, possibly miles across, but as big as possible, really, and low amounts of mass, then you can capture enough of that solar wind to literally sail on it and allow that to be your source of propulsion. So yeah, that's basically how they work. There's also I've seen some ideas of like micro is the right word for it, but or nano satellites. I think maybe they've called them that Elon Musk or SpaceX or some of those kind of companies have been working on, and the idea is you put a bunch of these tiny little things out in space and shoot them with a laser. And basically, the idea is that the laser is what gets caught on their sail, part of it, and that energy of the photons bumping into the sail is what causes them to accelerate at quite a great speed, in fact, or up to rather a great speed. And then you can set it loose to go travel to Alpha Centauri or whatever. And the prospect of getting there, in hundreds of years as opposed to like 80,000 years, I think is our current estimate, is pretty awesome. But again, you would just be sending something out there to collect data. It's not like a spacecraft that you could put a person on. From my understanding, they would be very small objects, just enough to collect information and possibly send it back to us. All right, I think that was good. Once we do reach a comfortable point with interplanetary travel, which planets do you think, will be most suitable for resource collection? I got to be honest. I think you know what, like the gas giants are cool and all that, and we love their moons because the moons seem to be promising, at least some of them, as potential places for us to inhabit in the future. But the planets would be worthless. I mean, unless you want to just go like pick up a bunch of gas. And I know that like beyond the atmosphere, I'm sure there is some other material or matter, whether if it's liquid or solid. But even like scientists don't really know like what is under, like the clouds, if you will, of Jupiter or Saturn and whatnot. So from that standpoint, I think we would be looking to any terrestrial type planet or planetesimal or moon or even asteroids. Asteroids, I think, could be pretty beneficial to us from the standpoint of there's a bunch of like metals and rocky types of materials that could be used then to make the Dyson Sphere or the other devices that we might want those resources. rather than literally mining and stripping the Earth of all that and putting it out in space. By the way, if you take enough stuff from Earth, you start maybe messing with Earth a little bit too much. Or like if you have any appreciable percentage of Earth's mass moving off of the planet because you're making some ginormous, structure somewhere else, that I don't know, it probably wouldn't have a huge effect quite anytime soon, but there's definitely a chance that something could happen. Okay. Oh, so which planets do I think? I believe, again, some of the moons out there, I can't think of which one it is now. It might be Titan is one of them. There's a few moons, though, that are like going around, or Saturn or Jupiter, that people believe would be a good possibility. Otherwise, I mean, realistically, I think we figure out how to survive on Mars. As much as I hate to say it, Mars would be a good bet. Or I almost wonder if Venus, if there's any chance. Now, right now, it doesn't look so good, right? But there's at least seems like there's a potential if we wanted to investigate a little further. And again, if we're going to be making a new, you know, planet for ourselves, then why not? Maybe we can try something like that. All right, let's move on to the next one. Have you heard about the recent stories about the United States and Israel being in contact with a galactic federation and having a secret underground base on Mars for alien research? What do you think about the whole situation? Is it a hoax? Okay, so disclaimer: no, I have not heard anything about this. Maybe I'm a little bit out of tune with any new news or conspiracy theories or whatever that may be. Um, but do I think this is possible, plausible? I guess I'm going to say no. I don't think this is true or even plausible from the standpoint of, while I do fully believe that we've got rovers and things like that on Mars, we've gotten things to Mars. I would not have. I would be super surprised. Let's put it that way. I would not put any money on the thought that there are humans or any underground research bases developed in any sort of a way that we could do alien research. Now, on the other hand, I wouldn't put it past governments with money to do something like this and hide it from the people of their nation. But at the same time, I just feel like that's a little bit too far fetched for my taste. So I don't think that would be possible. At least not this time. Okay. Realistically, which inevitable end of the universe do you think will happen? Heat death, the big crunch, or others, or never? Okay, cool. I did address this earlier, but I like the fact that it's kind of asking, really just getting to the point of it. I think if I had to choose, like which I think is the most likely to happen, I think heat death. The idea that the universe will continue to expand to a point where everything gets further from everything else, and it basically runs out of effective heat, if you will, to transfer energy and information from one location to another, and becomes basically just a cold, barren wasteland, if you will. Basically, the effect of being empty, not because it actually is empty, but because there is so much space between all objects that it's not really worth considering it to be like a full universe worth of stars and clouds and all the other cool stuff. So yeah, that's my thought on that one. All right, last but not least, all right, how long do you think it will take Earth to fall into a black hole? Do you think the sun will die before this happens? Okay. How long? Yeah, I don't know. Right now, I don't think there's any predicted, black holes in our future. Now, that doesn't mean that in the next couple billion years it's not possible, but I think our sun will die before this happens. Um, all evidence that I'm aware of suggests that, yeah, even before our Milky Way galaxy collides with Andromeda, Earth will have been either cooked or, if not, completely swallowed up by the sun as it becomes a red giant in its later life. And therefore, those Earth will not really be a thing anymore. It will have just become a part of what is the sun. And so, from that standpoint, that's still about 4.5 billion years away from now. So we got some time, but I feel like even between now and then, like the black hole, like just randomly, like rogue black hole coming through our solar system, sure, it's possible, but that seems to me not as likely. I feel like that would be later on. So That's my thought. I'm not worried about getting swallowed up by a black hole. Otherwise, that may be kind of cool, anyways. All right, awesome. Well, those are a lot of good questions. I'm not sure how well I answered any of them, but thank you, Celestial Al, for that opportunity. Let's go on and see who else has some questions for us today. All right, code name scientist Roger Roger. I like that. Okay, question one: how long could life on Earth survive if the sun stopped shining? Ooh, okay. I know I've read about this, and I know there's definitely some good, YouTube videos that probably describe this. I I think that like macroorganisms, like humans, trees, large animals, things like that. I want to say like they would most of us, most living beings would die or severely suffer under a year. I mean, because I want to say even like plants and things like that. I think if you literally had no sun, less than a month, I mean, they're going to be dead. I don't even, that might even be optimistic. I definitely have to talk to some biologists on this one, but I would think that's not going to be a good day, and it'll happen pretty quick after, um, you know, maybe even a few days, few weeks, for the larger, trees and plant organisms. They might live a little bit longer if they just have kind of that more energy stored up in their sugars and whatnot. But definitely no new source of oxygen producing because photosynthesis and all that dies. Things in the oceans would start to die because of, again, even the planktons and the other, seaweeds and other green type algae forms would start to die almost immediately, and so all the other parts of the food chain that rely on that would continue to die as well. So in a strange way, I think the humans would probably live about the longest of any species, simply because it's in our nature to kill everything else to help ourselves survive. So I think we would, if we had any sources of energy. Now, again, those sources of energy would have to be non-solar powered, which also probably means no wind because that's mostly driven by weather patterns and the sun. And so most renewable resources are almost out off the table. Nuclear power would be a great source to continue using because it is pretty long lasting and relatively clean. Coal, burning and things like that would be terrible still, but it would still be a way that we could probably continue to power our lives, if you will. But then we'd have to find ways to like artificially grow trees and have that, greenhouses and things like that with artificial lights, and then have animals that eat that, and then us eating the animals, or we cut out the animals altogether and we just go straight to, basically vegetarian diets and do what we can to survive that way. But I do think mass extinctions would happen pretty quick. Overall, like how long total, I would give, humanity, unless we found some major solution, like 10 years. I don't know. That sounds really short. I feel like it should be longer than that, but maybe we'll go 20 to 50 years. That's my totally rough, no experience guess on that one. All right, 3 minutes. Let's keep going. Do you personally believe humans can one day live on Mars? Yes, yes, I do. I think we will find a way. Again, I don't think it'll be in my lifetime, perhaps in your lifetime, but maybe in the next 50 to 100 years. I think that's possible. There, that can make up for some of the others. That's a good one. What causes the phases of the moon? That's a great question. So the phases of the moon has to do with the orientation of three objects. Okay, three objects: the Earth, the Moon, and the Sun. And so what I think is funny, and I always teach my wife and my kids, the dark side of the moon is not the same thing as the far side of the moon. Those are two different concepts. And the far side of the moon is not always the dark side of the moon. Because if you've ever looked at the moon and seen only a small crescent, we are actually seeing a good chunk of the dark side. But yet, all the time, roughly half of the moon is being illuminated by the sunlight. It's just a matter of what that orientation is compared to us and how much of that sphere we see illuminated. So the interesting thing is that when the moon is full, it is actually like in the opposite orientation. If the Earth was in the middle, the moon would be on one side of us and the sun would be on basically the opposite side of us. So that way, as the sun's light goes kind of around or past the Earth, it lights up the surface of the moon, and then that reflects back on the night side of the Earth, and we typically see that more easily. Okay. On the other hand, when you have the moon, what we call a new moon, where it is almost entirely dark, at that point, the sun would be more like behind the moon compared to the Earth. So it'd be like Earth, Moon, Sun. And so from that orientation, usually a new moon is going to happen more during the day or closer to daylight hours, simply because of the orientation of those three objects. And then you have things like the first quarter and the third quarter, and then you have the waxing crescent, and then the first quarter, and then the waxing gibbous, and then the full moon, and then the waning gibbous, and then the third quarter, and then the waning crescent, and then back to the new moon again. And so, with all of those phases, they all happen in a particular order because of, again, the rotation of the moon's orbit versus Earth's orbit, or Earth's spin relative to the sun. So that's pretty cool. And you can actually look up some really neat charts to see like when's the next full moon, and how that cycle works. It's a 28-day cycle. All right, awesome. Okay, that was it from scientist Roger Roger. Okay, I'm going to stop this video because I feel like it's probably gotten long enough as it is. But thanks for joining me yet again, and stay tuned for our next one. See ya.